For this video, I'm going to discuss about the analysis of determinate trusses, particularly on the first method or the method of joints. Okay, let's define what a truss is. The truss is one of the major types of engineering structures. It provides both a practical and an economical solution to many engineering situations, especially in the design of bridges and buildings. A typical truss is shown in the figure below, like this one. And a truss consists of straight members connected at joints. This one. It's a straight member connected sa joints. Thus, a truss members are connected at their extremities only. This one. Endpoints. Thus, no member is continuous through a joint. So, there is no such member as EB. It should be AD and EB. In the figure shown, for example, this one, there is no member EB. So, there are instead two distinct members, ED and DB. Most actual structures are made of several trusses joined together to form a space framework. In general, the members of a truss are slender and can support little lateral loads. All loads, therefore, must be applied to the various joints and not to the members themselves. Okay. Each member can then be treated as a two-force member, and the entire truss can be considered as a group of pins and two-force members. So, since wala ang load sa one, and in the middle or not at the joint, dapat ang load nasa joint lang. Therefore, all members are two-force members. One force acts at one joint or one end, the other on the other end. Since the truss members are slender. An individual member can be acted upon as shown in either of the two sketches shown below this one. So in the figure, if the forces tend to pull the member apart, this one, tend to pull the member apart, stretch niya, the member is in tension. If the forces tend to compress the member, this one, the member is in compression. So pag tension, the force is away from the joint, while ang compression, the force is towards the joint. So typical trusses are shown below. Typical bridge truss, we have this one. And then the typical roof trusses. Okay. Let's start with simple trusses. Consider the truss of figure A, this one. Okay. Having four members. If a load is applied at B, the truss will greatly deform. So the deformed shape is kining dotted lines. In contrast, the truss of figure B, this one, will deform only slightly. Even though there are only three members, pero ang configuration nila or ang placement sa members, it's different, mas rigid ni i-compare na niya. So the truss in figure B will deform only slightly under a load applied at B. The only possible deformation for this truss is one involving small changes in the length of its members. The truss of figure B is said to be a rigid truss, And the term rigid being used here to indicate that the truss will not collapse. So, dili siya makolapse. As shown in figure C, a larger rigid truss can be obtained by adding two members BD and CD to the basic triangular truss of figure B. This procedure can be repeated as many times as desired, like mag-add kag two members, add kag two members, add kag two. And the resulting truss will be rigid if each time two new members are added, they are attached to two existing joints and connected at a new joint. So kung mag-add kag duha ka members, o makonect sila sa duha ka existing joints, mag-add yun ka og bag-o na joint. Mo ni siya, no? Attached to two existing joints and connected to a new joint. A truss which can be constructed in this manner is called a simple truss. So, the first method that we're going to use in analyzing determinate trusses is this one, the method of joins. So, method of joins is suitable if it is required to determine the force of all members. Okay? For selected members, then you will use another method. Okay. Now we have learned that a truss can be considered as a group of pins and two force members. The truss can thus be dismembered. Pwede ito siya, bongkagon, eh? And a free body diagram can be drawn for each pin and each member. So each pin, there are 4 pins, A, B, C, D. So, nakay 4 pins. Free body diagram for each pin. Pin C, A, D, and B. And you also have the free body diagram of the 5 members. This one, EC, CD, BC, ED, and VD. Yeah. Each member is acted upon by two forces as well. Two forces. One at each end, this one. These forces have the same magnitude, same line of action, and opposite sign. So, pag example, 100 ne, 100 sign ne. Na opposite in direction. Therefore, the forces exerted by a member on the 2 pins it connects must be directed along the member and be equal and opposite. For example, this one, for this member. Ang force daw nga gi-exert ani na member on the 2 pins, pin C and pin B, must be directed along the member. So kung sa ang line of action nila, same also with this. Okay? Same line of action. Along the member man. And be equal and opposite. So, since equal ni duha ka forces, sa pin pod, kini na force is also equal to this. Is equal to this one. Kini na force. And then opposite. Third law ni Newton ba? For this one, going this way, 4th quadrant, then 2nd quadrant siya. Similarly, dire, sa Picas N, sa B, 2nd quadrant, 4th quadrant. Or simply, kung ang member is in compression, like this one, compression, pag-apply sa joint, compression sa, which is towards the joint. Towards man eh. Okay. So, after it is dismember anymore, if you want to dismember the truss, anyway, we're going to analyze the joint man. So, dito sa joint, apply na to ang conditions of equilibrium and then we'll be able to solve for the bar forces. Simple problem. Using the method of joints, determine the force in each member of the truss shown. State whether each member is in tension or compression. Okay, so let's identify the reaction. Since we only have a vertical external load, then the horizontal component of the reaction at B is equal to 0. And we only have vertical reactions at B and vertical reactions at C. So let us solve for the reactions. First, we sum up moment at B, then we can solve RC. This one. RC times 15.75 minus 945 times 12. And we can solve for RC. It's equal to 720 pounds. And summation of force equal to 0. We can solve for RB. Okay. It's equal to 225 pounds. Okay. So, first, let us analyze joint B. Make sure na there are only two unknown forces. No? Since we only have two conditions to use, summation of force along x equal to 0 and summation of force along y equal to 0. So, let's start with joint B. So, at joint B, we have this one, 225 upward, and then tension BC, horizontal, and then tension BA. Now, since this is inclined, let's have the components, X and Y. So, let us sum up force along the vertical, this one. Now, for this one, let us make use of slope instead of angle. So, for this member, let's determine the slope. We have vertical na 9 and then horizontal na 12. So, 9 over 12, if we reduce that one to lowest terms, it's 3:4. And therefore, the hypotenuse is 5. Therefore, the y component is TBA times counterpart sa slope 3 over 5. This one. So, TBA times 3 over 5 plus 225 upward money. And then transpose, we have TBA equal to negative 375. Or it's compression because it is assumed na tension siya. So, it is suggested na if unknown pa ang force, assume ka na tension so that every time pag mag-negative siya, you will just conclude na compression siya. So that you will not get confused. Kaya standard man mo pag-assume na tension. No? For as long as unknown pa siya, assume siya ka nga tension. Tapos pag mag-negative siya, hayaan mo i-change na compression siya. No? Para mas dali siya dili ka ma-confuse ba? Okay. Kung different yung mga assumption, ma-confuse mo. So let us sum up force along the horizontal or along X to solve for TBC. So based sa atong free body diagram, the two forces are directed to the right, so positive sila. And then we already have TBA, which is negative. We substitute na to negative. This one. And we can solve for TBC. So TBC is tension siya. 300 pounds tension. So, After this one, you can proceed to the next joint wherein there are only two unknown forces until ma-solve mo ang pinaka-last na force. Okay. Now, there is an alternate solution to this, especially if it involves three forces only. We call it the force polygon method. So sa force polygon method, advisable na siya nga gamiton kung tulo ra ka forces. Kay ang ma-form nimo polygon is a triangle man. Pag more than 3, basin complicated na. Okay. Madaghan naman ang sides. Pero kung 3 forces lang, okay lang kay triangle man. Okay. So what we will do is i-plot na to ang tulo ka forces, 225, TBA, and TBC. So let us start with 225. Actually, you can start with any of the 3 forces. Okay, so for now, let's start with 225, and then you connect the horizontal force TBC, tip to tail method. No? Ang tail sa next force, i-connect niyo sa tip sa last force. So, dari ang tail sa TBC. Okay. Tip to tail. So, the last force TBA, dapat ang tail na dari, ang tip na dari. Oh. So, therefore, ang TBA na ito, bali siya. Supposed to be first quadrant, karon third quadrant na. Which is correct kay compression man siya. No? So, dapat ang direksyon niya is dire. No? Compression siya. So, we have this right triangle and we just need one angle. We'll solve for this one. No? Okay. So, theta. Pag theta ni theta sa diya. Okay. Same naman siya. No? And from this one, we can solve for theta. Kaya theta masana. So, it's arctan of 3/4 or arctan of 9/12. Same lang. And theta is 36.87. So, with theta and 225, the opposite side, you can now solve the adjacent side and the hypotenuse. So, from trigonometry, we have this one, TBC equals 300 and TBA equals 375. Ang direction nila, dire ka mag-base. So, third quadrant man towards the joint na so compression siya. Kine to the right side, then tension. Next, so joint C or joint A. No? So, atas joint C. So sa joint C, we have 720. And this one, BC. Na-solve naman na ito ang BC. Okay. Tension siya, 300. Sa previous na slide na dito, na tension BC is 300. So ang ano na to is only this one. TCA. Okay. TCA. Components, X and Y, second quadrant. So ang X component is directed to the left, vertical component directed upwards. So summation of force along X or Y, depende. Isa lang ano. So pag X, using slope, then quantum slope, 9/3.75. So if you do that, 9 divided by 3.75, ang result is an improper fraction, 12/5. So it means na 12 ne 5 niya. And by Pythagorean theorem, ma-solve na to na 13. It's a special triangle, by the way. So sa X, component ba yun? 5/13. So yeah. Negative kay left man, negative TCA. And then X component niya 5/13 minus 300. And TCA equals negative 780. and therefore compression. And again, using force polygon, since we only have 3 forces, and then we have 720, and then i-connect nimang isa 300, and then fourth quadrant ang PCA. Okay, so i-base ito din sa free body diagram, fourth quadrant siya, towards joint C, compression siya. So tama niya. So again, sa force polygon, given ang duha ka legs, you can solve for the hypotenuse using Pythagorean theorem. And the answer is 780. Okay. So, inaanaan lang ang one, ang sa method of joints. You start with the joint with only 2 members connected, since we only have 2 equations to use. And then after that, proceed to the next joint with 2 members, 2 unknown forces, and continue either from left to right ang movement nimo or from right to left, for as long as every time mo analyze kag joint, there must be only 2 unknown forces. Another sample problem. Using the method of joints, determine the force in each member of the truss shown. State whether each member is in tension or compression. Again, we only have vertical external force, then the horizontal component of the reaction at D is 0. We only have the vertical component and the reaction at E. And then solve for the reactions. Summation of moments at D, we can solve for RE. And the answer is 528 pounds. And then sum up force along the vertical, makuha nimo ang RD, which is equal to 165 pounds. You are now ready to analyze the truss or solve for the bar forces. Okay, so based sa truss, you can only start either sa D or E with two members connected na unknown. Dili pwede sa C, 4 unknown members, A, 3, B, 3 members also. Okay, so let's start jointly. So for this one, instead of slope, angle na santa. Okay. You have 165 and then TDA. Let's denote na angle alpha na siya. The direction of TDA from X. So, what's the value of alpha? We get the slope of this side, this member, DA. So, we have 12 over 5. So, you have 5 and then 12. So, 13. So, if this is alpha, then this is also alpha. Kana. And we can solve for alpha. Either you use arcsine, arccosine, or arctangent. Let's use arctangent. And alpha is 67.38. Next is this one, TDC. And then let's denote the angle of TDC from the horizontal as theta. Now, ang geometry sa truss is symmetrical. So, symmetrical. Therefore, ang slope sa DA is the same sa BE. And also, the slope of DC is equal to CB, also equal to CE and BE. Same lang muna. No? So, okay. So, instead na dire lang sa same lang na sila. So, Now let's divide. This is 12 and this is 16. A triangle, 12 and then 16. So if you reduce that one, that's 3/4, no? 3 vertical, 4 horizontal. So 4, 3, and the hypotenuse is 5. So kung theta ni siya, kini ang angle ni theta, theta sa ni siya. So theta sa na. So solving for theta, we have this one. Arctan of 3/4, and we have theta equal to 36.87. And after this, make use of the conditions of equilibrium. Summation of force along the horizontal equal to 0. Force going to the right, positive. Now, the components of TDA and TDC along the x-axis, puro siya right, no? Directed to the right. So, positive ang duha. TDC cosine 36.87 plus TDA cosine alpha. Okay, next, summation of force sa y. Since first quadrant, ang y component sa duha ka forces are all upward, directed upward. So positive ang duha. 165 is positive also. So you now have two equations with two unknowns. So in order to solve for the unknowns, you can use method of elimination as discussed sa algebra. You can also use your calculator if it is capable of solving equations. So, di na mag-explain sa method of elimination using calculator. TDC is 125 pounds and TDA is negative 260 pounds. So, conclusion, TDC is tension, T, while ang TDA is compression. Kaya nang negative man. Kana, no? So, after solving for these two forces, you can proceed to the next joint. Na, ang next joint ni mo is A. Okay. Solve na yung DA, DC. Di mo ka pwede sa C, kaya pa makitulo ka members. So, sa A ka. Diba? So, sa joint A, we have this one. Oh, na-solve na niya. DA na to, 260 compression. And then, ang unknown na to, assume tag tension. EB, the same angle alpha. And, mo na siya. TEB, and then ang TEC, tension also, kay unknown man. And then theta ni. Theta. So, mo ni ang value sa alpha and theta. So, summation of force sa x, the component of TEC along x is directed to the right, positive. The x component of 260 is also directed to the right, positive also. And then ang TEB, positive also. Okay, summation of force sa y equal to 0, upward, positive. So, the component of 260 is upward, along the vertical is upward, so positive. The component of TEC along the vertical is downward, so negative. This is the result. So, from this one, from this equation, you can solve for TEC. And then after that, i-substitute ni mo ang value dire, makuha ni mo ang TEB. So we have TEC and then TEB. So therefore, TEC is 400 pounds tension, TEB is 420 pounds compression. Okay, so we have solved already 4 members, DA, DC, EB, and EC. So the remaining 3 sides na lang. So pwede na ka ma-proceed sa either sa B, 2 unknown members, sa C, 2 also, and E, 2 members also. Okay, dito, joint E. Okay, so 5, 2, 8, and then tension EB, and then alpha yapon. Same lang sila, alpha. And then tensions EC, theta yapon. And these are the values of alpha and theta. Summation of forces ga. Since second quadrant silang duha, ang ilang x component directed to the left, puro negative. And then summation of force sa y equal to 0. The y component of the two unknown forces are all directed upward, so positive, including ang 5, 2, 8. And again, to solve for the unknowns, you can use method of elimination, or you can use your calculator. TEC is 400 pounds, positive, TEB negative. So therefore, EC is, EC niya, tension EC. 400 pounds tension, and then EB, 832 pounds compression. So the remaining member nga ma-solve is BC. Okay, let's consider joint B. So sa joint B, na kay 693 pounds downward, and na kay EB, na-solve na siya, as well as BE. So ang BE na to 832, and then ang EB, alpha oh. And then 420 compression man to. Patong gisolve ka ganina. And this one, ang unknown na to, TBC. Again, pag unknown pa, tension ng assumption. And then theta. Okay. Since we only have one unknown, you can use either sa duha ka conditions. So either this one, summation of force sa x. Okay, the x component of 832 is directed to the left. X component of TBC left also. So duha ka negative and one positive. TBC is equal to 125. So tension. Now, if you want to check if our solution is correct, you can apply or you can use this condition. Summation of force along y. X sa mga nagamit, di ba? I-check na ito. Summation of force sa y equal to 0. Downward, negative. This one, upward, positive. This one, downward, negative. I-check na to kung if it's really equal. And pag-compute, mo niyang result. So, kini siya is round of errors. Okay. So, nag-round off man ta, so expect na error. Pero kung dili ka mag-round off, exactly gina siya, equal to 0. So, therefore, equilibrium. Okay. Now, the alternate solution is my own technique. Okay. This is called the Neris LABAY2X technique. Okay. So, the basis is this. Let's start with this. You have the force magnitude, and after drawing a rectangle, the sides of the rectangle are the components Fx and Fy. And then, if you draw the if you get the distance between 2 points at force nimo, distance between this one, tail and tip, and then D na siya. And then draw a rectangle. Ang components sa rectangle, X and Y distance. And by ratio and proportion, we have this one. Fx over f equal to Fy over y equal to F over D. Now, in most cases, sa analysis of trusses, ang given values or forces are vertical. So, assuming known ang value sa x, y, and d, sa slope ha, sa slope sa member, known ang x, y, d, like 3, 4, 5, 5, 12, 13, 8, 15, 17. Those are special triangles. No? So, mean to say, given ang x, y, and d. Now, sa forces, since usually, if y ang given or y component ba, kay vertical mo ng mga forces. So, how are we going to solve for the magnitude as well as the x component? So, we will make use of this proportion. So, to solve for the magnitude, given magnitude f or resultant, to solve for the resultant given the y component, so how to solve for f given ang y component? So consider these two. Then your f is this. Fy over y times d. Similarly, sa x, to solve for the x component given y component, focus on this. Then fx is equal to Fy over y times x. Now, let me illustrate. Suppose you have this joint and you have two unknown forces T1 and T2. Instead of using conditions of equilibrium like summation of force along x and summation of force along y, okay, let's analyze this one practically, okay, using my technique. So, remember that ang purpose na to or ang objective na to is ma-zero ang joint. Ma-balance, equilibrium ang joint. So therefore, balance ang forces. Balance ang horizontal, balance ang vertical. Now, for T1, this is an inclined force. So, kung paano to components, nasa x component and y component. Now, given man yung vertical, para ma-balance ang forces sa y, dapat kaning 200 na upward, i-counter na siya. O downward, same magnitude sad. 200 sad. Para inig-add nimo sa duha ka forces, zero ang result. Di ba? Balance na siya. Now, okay. Mo na ni karon. If given ang vertical component, how do you solve for the x component? Diri ka. Kaya naman ka slope. Okay? Pero, okay. Ima sa di-recall na dire, ang component sa force o ang resultant, mag-meet ilang tail. Mag-meet sad ang ilang tip. So, i-transfer ni mo ng Fx sa ibabaw, na dire yung arrowhead or ang tip. And then Fy also, i-transfer mo dire, nasa dire yung tip. So, ang condition na is dapat ang components o ang magnitude mag-meet ang ilang tail or mag-meet ilang tip. Now, in this case, naman dire ang tip sa vertical, nasa diha ang tip sa horizontal. And sa value, okay, gamitin natin Bali, 200 over y. Ang y niya is 4 times horizontal x, 3. Ano? So, T1x component, no? X component. So, this one, Fy over y component. Counterpart sa 200, there is a slope is 4 man. 200 over 4 times 3 para sa horizontal. And the answer is 150. So, 150 na. And again, kung mag-meet ang components, dapat ang imong magnitude diri sa diyan tip. So kini ato ni i-change. Mahimo na ni siyang kana. So therefore ang T1 di is compression. Now, how do you solve for T1? O diri na sad ka. Saan pag-solve sa magnitude? Kana na sad. 200 i-divide sa iyang counterpart na vertical for i-times ni mo 5 horizontal mo ng ano. The answer is 250. So T1 is 250. And then, okay na, balance ng vertical, horizontal. Nasad. We have 150 going to the left. And then we have T2 na unknown. Assuming na right, no? So para mo-balance, 150 sa niya. Para inig-add ni mo sa duha ka horizontal forces, 0 ang result. So yun na ang labay-labay technique. After this, i-transfer ni mo opposite in direction. Like, suppose ang isa ka joint is na dire. Ang imong T2 na 150, it should be directed to the left. Kay tension man. Ana. So after one joint, proceed sa next joint until sa pinaka-last. Okay, so as an illustration, let us solve this sample problem. Determine the force in each member of the truss and state if the members are in tension or compression. Okay, so reactions RA and RD. Sum up ka og moment sa D, you solve for RA. 2,000 and summation of force along Y. Makuha ni mo RD, which is 4,000. Okay. Now, slope na yun. 10:10, so 1:1. Okay, so 1:1, the hypotenuse is square root of 2. So, we have the reaction, 2,000 and then 4,000. So, ato ni siyang kuan, pamagkatag section, mo niyang result. Kana, no? Para labay-labay ba? Okay. Now, para gagmay lang ang values to consider, instead na 6 pound, let's replace this one by 6 kips. Ay, anyway, mo din ang slope po, 1:1 and square root of 2. Let's go back. Replace 6,000 pounds by 6 kips. And then same also with reaction. So 2 kips and 4 kips. Okay. Let's start with joint A. So joint A, nakay 2K na 2 na upward. So ang unsay mo balance aning 2 na upward. It's only the vertical component of EG. Okay, horizontal mo ning imong EB, wala siya Y component. So ang mabalance sa 2 is the vertical component of EG. 2 sa na siya. So again, given a vertical, how do you solve or determine the horizontal component? By ratio da. 2 divided by 1 times 1, 2 sa na siya. Timani ha, magtagbo gidapat ang tip or tail sa components as well as the magnitude. So compression din siya. Okay, basta orange na semi-brown compression na. So how do you get the value of this? Ratio na sad ka. 2 divided by 1 times square root of 2. So this is 2 square root of 2 or 2.83. Okay, after that, unsay mo balance? Balance na vertical, horizontal na lang. Nakay 2, paingon sa left, dapat i-balance na og 2 sa paingon sa right. Tension siya. No? Tension. Balance na. Proceed, ayun ka. Joint B. Tension, gyapon na. Tension. And also there. Compression. Compression man there. So compression. And then we have components 2, 2. Now, dito ka-analyze sa G, kay natin tulo ka-unknowns pa. So, dito sa B. So, sa B, naman kay 2 paingon sa left, i-balance na siya og 2 paingon sa right. And then, atong vertical, isa ra atong vertical, oh, wala line balance. Therefore, 0 na siya. Okay. 0 na. Now, after this, mo transfer ka diri sa C, you still have 3 members na ano, so diri ka sa G. So, duha, horizontal, and then components ni vertical, horizontal. So, sa horizontal, di pa ta kasolve kay duha pa man ang ano, dito sa vertical. Na natin 2 upward, i-balance siya og 2 downward. Ana, 2 sad na siya. O kay 0 man eh. So 2 upward, 2 downward, di balance ang forces sa Y. Now, with this vertical component, even sa determine ang horizontal component, same ratio, 2 divided by 1 times 1, 2 sad na niya. Oh, remember magtagbo dapat either ang tails or heads. So, naman din ang tail sa duha, therefore ang magnitude nimo na po diha ang tail. Paano sa oh. Tension din siya. Ang value anara 2 over 1 times square root of 2. It's 2 square root of 2. So 2.83 also. And then ang mabalance dire GE, no? Tanawa ang horizontal. You have 2 and 2 going to the right. So ma-add sila mahimo 4. So dapat i-balance na dire 4 po. Okay. So balance ang vertical, balance po ang horizontal. And then you proceed to the next joint. Di labay ni mo dire. Kinilabas ni mo dire. Tension. Tension sa na sa labay. Components na yun, X and Y. So, away ya. So, away siya na. Okay. So, pwede na ka mo proceed sa joint E, duha na lang, joint C, duha, or joint D, duha. Okay, sa C na lang. Now, vertical sa C, na kay 6 downward. And then you only have 2 upward. So, kulang ka og 4 upward. Kana 4 na siya. And then sa horizontal, na kay duha nga paingon sa left. So i-balance na og 4 sa paingon sa right. Okay. And then proceed sa E, na kay 4 tension. Okay. The last is member DE. Okay. And bungkago mo siya into components, vertical, horizontal. Naman kay 4 paingon sa right, therefore paingon sa left. And then by ratio, 4 over 1 times 1, 4 sad na. Oh, 4 also. So, considering joint, i-balance ang horizontal, balance ang vertical. And then, labay na po na to. Labay, sorry. Yan sa magnitude niya. It's 4 divided by 1, and then the result times square root of 2. 4 square root of 2 is 5.657. And then transfer 4, and then kaya yun. X component 4, compression man, and Y component 4. So, i-check ni mo, horizontal forces, balance, vertical forces, balance. Okay. So, yung una na ang akong labay-labay na technique. Now, if you will check the values, if correct, we can use any software. For this one, I'm using the MD Solids na software. Same result. 283 compression, 2 tension, 2 tension, 4 tension, 2 to 4. Iba about GE 4 compression. This one 0, 2.83 tension, 4 tension, 5.66 compression. Okay, so that is my labay-labay technique. Yeah. So I hope that you have learned something. Thank you for watching.